hello and welcome to my first virtual lesson. Today we're going to be going over how to calculate the volume of a cylinder. So, as you recall, yesterday we have reviewed how to calculate the area of a circle. And that's the first thing we're going to need to know how to do when we're calculating the volume of a cylinder. It's pretty much just adding one extra step after calculating the area. So the first thing we need to do is we need to look at our cylinder. Let's remember the relationship between our radius and diameter. Who can tell me what the relationship between the radius and the diameter is? That's right, the radius is half of the diameter, or the diameter is twice as much as the radius. Which one do we need to know to solve our area and volume problems? That's right, the radius. So let's look at my cylinder here. Let's say we have a radius of 5. Who can tell me the diameter? Good, 5 times 2 is 10. So the diameter is 10. Now we're going to add another measurement to our cylinder. We're going to add a height. So for this particular cylinder, we're going to say that the height is, see if the radius is 5, we'll make the height 10. Oh, same as the diameter. So the radius is 5, the diameter is 10, and the height is also 10. All right, so let's review how to calculate the area of the top of our cylinder. First off, what is the formula for calculating the area of our circle? How can we find that out? That's right, we're going to take out our MCAS reference sheet. Under area, we see that the formula for circle is area equals pi r squared. Area equals pi r squared. So now that we have our formula, we can start plugging in the various numbers. So we're going to bring down our A. We don't know what the area is yet. That variable we do not know. That is an unknown. The pi is a constant. It does not change. What is pi? 3.14. Good. Unfortunately, 3.14 equals pi is not going to be on your reference sheet. That's something we're going to have to remember when we take our MCAS. However, I want you to remember that we never, ever, ever use the pi button on the calculator. Your calculator for the MCAS will not have a pi button. So we plug in the value of pi. So we're going to replace the pi symbol with 3.14. We're going to put it in parentheses because we want to separate it from the radius. What does it mean when we multiply, when we put 2 parentheses around our numbers? It means we multiply. So we're going to bring down the radius squared. All right, we still don't know what area is. We do know what pi is. Do we know what the radius is? Yes, the radius is 5. So we're going to continue to bring down our equation. I'm going to change colors, Area equals 3.14. We're going to plug in our r. Radius is 5. So we're left with the equation, area equals 3.14 times 5 squared. Now, think about your order of operations, your PEMDAS. What comes first? Well, we've already completed what's in the parentheses. What's next? Exponents. Do we have an exponent here? Yup, we have 5 squared. So how do we solve 5 squared? What's the biggest mistake people make when we try to solve 5 squared? People try to multiply 5 times 2. The correct way to do it is 5 times 5. 5 squared equals 5 times 5 equals 25. So now on our next line, we can plug in that 25. We still don't know our area. Do we know our 3.14? Yep. Have we solved our radius squared? Yep. All right, so what is our last step? Our last step is to multiply our pi times our radius squared. Now I can do a lot of mental math. I did not need to write that. Everyone makes mistakes, especially Mr. Fitzsimmons. All right, so we're going to multiply 3.14 times 25. Who has it? 78.5. What's the label here? The label is units squared. It's units squared because I did not put a measurement next to these numbers. Therefore, we use the default units squared. Now we're going to try it with volume. Let's find volume on our MCAS reference sheet. We are doing the volume of a cylinder. On your MCAS reference sheet, it kind of changes the wording a little bit. And it's a right circular cylinder. It has a right angle at the side, and we are determining the circle cylinder. So let's change up our numbers a little bit. What should the radius be? And I don't want anybody giving me a million. Let's make the radius. Actually, let's start with the diameter. What can the diameter be? 12. Now the radius. How do I determine the radius from the diameter? We divide the diameter in half. What is half of 12? What's an easier way to solve that? 12 divided by 2. Another way to say a half of a number is to divide it by 2. 12 divided by 2 is 6. So we know our radius and diameter. I'm going to give you the height. I'm going to say the height is, let's do 10 again. I like 10. So now I'm just going to label my cylinder. The radius is 6, the diameter is 12, and the height is 10. Let's add some labels here. We did units on the last one. Let's say this is inches. A couple of different ways to write inches. Well, let's use the abbreviation. So now, who can tell me what the formula for determining the volume of a right circular cylinder is? I'm gonna cheat. I'm gonna look at it. I don't have it memorized. And you don't have to have it memorized either. The formula for the volume of a cylinder is volume equals pi r squared times height. So once again, we can plug in the information we know on the next line. Do I know the volume? Not yet. Do I know what pi is? Pi never changes. It is a constant. Do I know what the radius is? 6. And the height. The height is 10. What happens if I leave it like that? It's going to be a little confusing in a while. So I'm going to put parentheses around all 3 values. That way I know that I'm multiplying each number. All right, so let's think once again about PEMDAS, order of operations. What is our first step? Do we have anything to do in these parentheses? Not really. Do we have any exponents? Yep, so we're going to solve that exponent. Who remembers how to solve 6 squared? 6 times 6 is 36. The 10 stays the same. So now in order to determine the volume, I have volume equals 3.14 times 36 times 10.
Tanya Mello, line 2, Tanya, line 2.
No shame in the calculator game. 3.14 times 36 times 10. Did we get a difficult decimal answer? Yeah. Did we all get the same answer? 1,130 and 4 tenths. We don't say 0.4, we say 4 tenths. Our volume is 1,130 and 4 tenths. Now, what is this problem missing? It is missing a label. What is my label? Inches squared. Awesome. And that is how we solve for volume of a cylinder. All right, you guys ready for the fun part? We are now going to measure the volume of the very sought-after roll of paper towels. In the age of coronavirus, this has been very challenging to get, never mind getting one for each of the class. So we are going to measure the diameter, the height, and we're going to see if we can figure out the radius. So you have 2 different types of measuring devices on your table. We have a ruler, which I just realized I'm holding the imperial ruler, the one with inches. So I'm going to move over to my handy dandy yellow fabric tape measurer. So we are going to measure our paper towels, and I want you guys to do it to the nearest ½ inch. So let's see if we can measure our paper towels to the nearest ½ inch. All right, let's see if we all got the same answer. A little harder to hold up. What do we think? I said ½ inch, I meant ½ centimeters. Good call. All right, So we got a measurement of 28. Was that the height, the diameter, or the radius? The height. So the height of our paper towel is 28. 28 what? Centimeters. What is the diameter of our paper towels? Now, it's not a perfect cylinder. It's kind of squished in some places, so we might have different answers. So let's see if we can come up with a couple of the same answers, then use that number so we're all the same. Oh, I got, what do we got? 14? Let's say 14. So our diameter is 14. So if our diameter is 14, what is our radius? Use your calculator if needed. We are dividing by 2. 14 divided by 2 equals 7. Our radius is 7. So now let's label our cylinder. We have a height of 28. We have a diameter of 14 and a radius of 7. Now which number here don't we need? We don't need the diameter. All right, so on your paper we're going to rewrite the formula. Once again, if I need the reference sheet, don't feel bad about getting the reference sheet. Volume equals pi r squared times height. So who can tell me the next step? We are going to start plugging in the information that we have. Do we know the volume? Not yet. So we're going to bring down volume. Do we know pi? We do know pi. Do we know the radius? The radius is 7. So we're going to do 7 squared. Now we could do this step on the same line, but let's take it a little bit slower. Do we have the height? 28. What's the next step? We're going to square our 7. So who can tell me 7 squared? Not 14, but 49. So once again, we're going to bring down what we know. We know the 3.14. We've solved for 7 squared. And we have the 28. So in PEMDAS, we're done with parentheses. We did exponents. What's the M stand for? Multiplication. So let's multiply those 3 numbers together. As soon as I find my calculator. So we have 3.14 times 49 times 28. What do you notice about your number? It's a big number. The bigger numbers we use here, the bigger numbers our final answer is going to be. Our volume equals 4,308.08. What is the correct way to say that? 800ths. All right, what is our label? Centimeters cubed. Oh dear, I've made a mistake all class. I really don't want to go back and record this. I made a mistake. It's not centimeters squared. What does centimeters squared refer to? Area. It's supposed to be centimeters cubed. I made a mistake. Let's rewind back to 8:30, the beginning of class, and do this all over again. No, let's not. We'll go over how to do volume labels in a little bit. All right, so we've measured our paper towels. What else do we have on our desk? Stop laughing. Toilet paper. So what I would like for you to do now is to measure your toilet paper, and we will go over the measurements together. I'm going to pause this video, and then we're going to take a look at it.